welcome back, Life Sciences. Right, just a quick recap. We're looking at proteins today, right, and we're looking at enzymes, and we're looking at why it's really important that we have them in our diet, and especially how enzymes are going to work. Those biological catalysts that get things ready, right, and going in our bodies. We're now going to look at a few possible questions that we could ask on this section. Let's see if we can, right, master through them. Okay, guys, the first one is just going to be, it's going to be a multiple choice question. It's just let's get us into the groove of this proteins. The giant organic molecules, right, really telling us they're nice and big, containing the elements C, H, O, and N. As soon as you see that N, right, your brain must be going, okay, I know what this is. And sometimes sulfur, right, whose function is to repair worn out tissues. Right, now have a look here. This is going to be the very key phrase. Number A is amino acids. And I think a lot of you might say yes here. But amino acids are the building blocks, so they are small. So you might think, oh yes, amino acids does have nitrogen, but they said here the giant organic molecule. So that is going to be a no. Number B is proteins, right? What do we know about proteins? They're made of carbon, hydrogen, oxygen, nitrogen, and they are really big, so that is a definite possibility. Carbohydrates and lipids both only consist of carbon, hydrogen, and oxygen, so they are not going to be part of the equation. So the answer is going to be number B. Okay, another multiple choice question, but just giving you a diagram. As soon as you see the diagram, I'm hoping that you can start to think lock and key enzymes. Right, the diagram below shows enzyme action. There we've got a whole lot of letters that go with that. And the question is, what is Q, right? Which part is Q? Now, number A says it's an enzyme. Now, if we have a look, an enzyme doesn't change shape. And if we have a look at Q, it changes shape. So, no, it's not going to be A. Number B says it's the enzyme substrate complex. So, it's where's the enzyme? Here. Where's the substrate? Here. So it's going to be R. That is definitely not Q. So number B is not going to be my answer. Right, number C is the product. That's the end result. The end result is here. That is going to be number T. Is it number Q? No, it's not. Which leads me, right, to the last answer, which is going to number D. Is it the substrate? Definitely. Right, here's my enzyme, here's my substrate. My enzyme's going to work on my substrate, so my answer is going to be number D. Okay, our next question, right, is going to be a little bit of a longer question. An investigation was carried out to determine, all right, as soon as I see the words to determine, what must my brain tell me? This is my aim. This is the aim of my experiment. To determine the effect of temperature on enzyme activity. So I need to see, does temperature affect how an enzyme works or not? Okay. The next thing is the results of the investigation are in this graph. So this is the graph that is going to, after I did my investigation, here's all the different temperatures on the x-axis. Here's how the enzyme worked on the y, and now I'm going to see what happened. Did temperature have an effect, right, on the workings of my enzyme? Okay, the first question, what was the aim of the investigation? We are now going to go 2 slides back. You go back to what the heading was, what I did here, and what do? You take this out and you write it exactly like this as your answer. As soon as you see the word to determine, That means we always use it to determine what are we going to do. This is your aim. So you take it as if you were going to, all right, like English, you're going to paraphrase, you're going to quote, and you take that and you take it and take it out of your, right, of your introduction. Okay, scientific, here we need to go. What is the dependent variable? Dependent variable, all right, is the results. And where do we put the results? Always on the y-axis. Okay, so what is the dependent variable? It's enzyme activity, the percentage. In other words, how does the enzyme work? All right, the activity. Is it working or isn't it working? That is my dependent variable. On my x-axis over here, right, is always my independent. What does I start with? I decided. What did I choose? I chose the temperature. So my independent variable is temperature and degrees Celsius. Okay, guys, when I'm planning something, what am I going to do? Right, I'm going to plan an experiment. What must I have? It says here, what is the things I need in the investigation? Our time is running out, I'm afraid. It's actually over. So I'm not going to be able to answer this question, but you guys are now going to think about it. Right, I want you to go now. I want you to think, I'm going to do investigation. What must I have in place? Right, obviously a thermometer, maybe some kind of different temperatures, all those things. Okay, that's all for us from today. Have a wonderful day, Life Sciences. We'll see you next time. Bye-bye.